What's up, guys? Just going to go through this real quick with you for your notes for today, for Monday. But first, we're going to have a little reminder of the right triangle vocabulary. Those of you who sang the song, it should be pretty simple, so you will be able to get through that pretty easily. First, we got these two sides that are not the longest side. Those are called the legs. B for the bottom one is usually what I call it, and I usually call the other one A. You're going to notice that right here you have a right angle. They're telling you it's a right angle because of that little mark. And that means if you go to the opposite side, that's the hypotenuse. All right. Now, the next thing that you're going to have is right there, the hypotenuse. So that was from your song. So hopefully you remember that. A and B are the shorter sides. So a squared plus b squared equals c squared. C is the length of the hypotenuse. A and B are the other sides. So once you find that hypotenuse, either one of those, A or B, could be the other ones. They're called the legs. All right. So in Pythagorean theorem, it says in a right triangle, a squared plus b squared equals c squared. But if you want it in math words, it means in a right triangle, the sum of the squares of the two legs, so the square that's out here plus the square that's out here equal the square that's out here. That doesn't tell you how long anything is, it just tells you how big squares are. So keep that in mind. That's a big problem for 8th graders. That means this square plus this square equals that square, right? If I want to know how long anything is, I always got to do the square root. So if this was 9, square root of 9 would be 3, and this would be 16, that square root would be 4. All right, that is your Pythagorean theorem. Notice that a squared plus b squared equals c squared. And that right there is what we're talking about, these lengths. Okay. We're going to use it to find any side. So here's something a little different. I know how big this side is, right? I know how big that square is, I should say. I don't know how big this square is, but I do know how big this square is. So what we're going to do is we're going to say the area of the green square plus the area of the blue square, because a squared plus b squared equals c squared, and is going to equal 100. So 36 plus something equals 100. You would know that in order to do that, you would subtract 36 from 100, you get 64. That means this square, this one, is 64 units big, but that's not how long that line is. That line is the square root of 64 long. What number times itself is 64? Hopefully you know that. And in your mind, you're thinking, okay, hold on, come on. That it's 8. If you were thinking 8, this is for you, right? Good work. Okay. So now we can use the Pythagorean theorem not only to find out how long the longest side is, we can find out how long one of the other shorter sides is. So a squared plus b squared equals c squared. If you have a c squared, you're kind of subtracting now, right? That makes sense. You're undoing it. So here's this example. We're going to see the exact and the estimated lengths. So first off, which one is c? It's not always the one up here. I'm going to find this little mark. I'm going to go across, and it's going to be the longest side. This is the longest side, and it looks like it's the longest. So this is my C. That means that one of them is A, the other one is B. Okay, it doesn't matter which one's which. You just choose whichever one you think, whichever one you want to be A and B. All right. Write the Pythagorean theorem. A squared plus B squared equals C squared. And I know what A is, so I'll put that number in. I just plug it in. A is 5, so 5 squared. B squared, I don't know, so I leave it as B squared. Equals, C is 13, 13 squared. So now when I look at it, I simplify it. So 5 squared, it's easier to say 5 squared is 25. B squared, I don't know it. I leave it as B squared. I'm fine with that. 13 squared, I can simplify that. Get your calculator. 13 times 13, or use the button on the calculator, 13 squared. It's 169. Now this problem says 25 plus some number squared equals 169. So what I'm going to say is that means 25 plus something equals 169. So in order to figure that out, I would subtract 25 from both sides. And I would see that this big square has an area of 144 square units. That's not how long this side is. That's not how long this side is. So be careful with that. What do I do to find out how long this is? How long a square is? It's the square root of the area. So I would then take the square root of this big square. So square root of 144. That means what number times itself is 144? And that number is 12. So this B is 12 units long. That's its exact and its estimated length. We don't have to estimate it because we know it. It's 12. All right. So its exact is 12. It's estimated. We don't need to do it because we know what it is. It's exactly 12 meters long. All right. So here's another example. I'm going to take a look here, and I see that they have, this is the hypotenuse because this is the right angle. I look straight across. That's the hypotenuse. So they have given me C, right? They have given me B, and I like to put it here because that's the base. It doesn't have to be. You can call it A if you want to. And this would be A. I'm trying to figure out what are the legs. Okay. Write the Pythagorean theorem. A squared plus B squared equals C squared. And I plug in what I know. I don't know A, so I leave it as A squared. That's okay. I do know B. B is 11, so I put 11 and I'm going to square it. I do know C. It's 15, so I put 15 and I'm going to square it. Then I use my calculator. I still don't know what A squared is, so I'm going to leave it A squared. 11 squared is 121. 15 squared is 225. And I know that this square plus this square, I don't know what it is, equals this square. So I know these two. How would I find this other one? Subtract, right? If I subtract out the 121 from both sides, if I take out the 121 squares over here, it'll leave the squares that fit on this side. And that would be 104. So my question is, what number times itself is 104? Well, I know 10 times 10 is 100. 11 times 11 is 121. So it's going to be an estimated one, right? I don't know what that will be because I'm going to take the square root. What number times itself is 104? I don't know it, so I'm going to estimate it. The exact length is the square root of 104. And the that's the exact length. The estimated would be about 10.2. Okay. So once you find this number, you have to take the square root next. That's going to be your most common mistake. Okay. So if you can do that, you'll be good. All right. So let's look at this one again. Taking a look, and this time they didn't tell me C. So I have A and I have B. That means I'm going to use the Pythagorean theorem in its normal form, but not have to subtract. I'm going to be adding. So A squared plus B squared equals C squared. And A is 6. So 6 squared plus 16 squared equals C squared. So that means 36. There is the square on this side. 256 is the squares that are on this side. And I'm going to see if I add them together, it will equal 292. That's how big this red square is. That is not how long this side is. If I want to know how long the side is, I take the square root of the area. So I'm going to take the square root of 292, and that will give me, well, what number times itself is 292? I'm not sure. So that means it's an irrational number, and I'm okay with that. I'll just write that square root 292, put it in my calculator. Square root 292 is about 17.1 centimeters. So if I went into Lowe's because I wanted to buy some wood to make a triangle-shaped flower bed in my backyard, and I used the Pythagorean theorem, I wouldn't go in and say, hey, I need a piece of wood that's the square root of 292 long, because the people at Lowe's probably can't tell me how long it is. I've got to tell them, right, make it 17.1 meters, 17.1 centimeters. So that's why we're estimating. Okay. This will be your final answer. So what you're seeing for today is we are now saying you can find sides that aren't the hypotenuse, right? So yes, last week, A squared plus B squared equals C squared looked just like these problems. We took the square root. You were adding, right? You're adding those numbers. Now we're saying if you get the other side, if you get one of the legs, you have to subtract, right? Hopefully that makes sense. And if you need help, let me know. But other than that, I think we're good. So I'm going to say for now, a squared plus b squared, b, seeing ya.